My name is Yujin. I'm the host of the show. Today we're going to be talking with Chang from Lance. Yeah, so LanceDB, tell us a little bit about like the evolution of how this came about.
Yeah, of course. So my career has been basically like dancing that around that border between databases and machine learning. I've been building data tools for data science and machine learning for about 20 years at this point. I started out my career as a quant, and before data science was a job title. If you liked working with data and you were technical at the time, pre-financial crisis, you went into quant finance, and so I did that. And then I got into Python open source and ended up being one of the earliest contributors to the Pandas library. And that's sort of what lit the spark for for me, for open source, for data science and machine learning. And I've sort of been on this path since. I've done a bunch of big data stuff at Cloudera, and then I worked on recommender systems at 2BTV. And it was there that I sort of got to the idea for LanceDB, which was if you were building machine learning on tabular data, life wasn't perfect, but it wasn't so bad, right?
Sure.
Pandas was a big help for small data. Polars wasn't quite around then yet, but there were lots of other data frame choices and distributed engines and SQL and all that. So you had like a whole ecosystem of tooling around that. But at Tubi, it was a streaming company, and so we had to deal with the video assets, we had to deal with the artwork, and whenever we dealt with that kind of unstructured multimodal data, it took a lot longer. The data management was difficult. It was hard to find an existing system that performed really well. So some of them were a good fit for one type of task and one type of data, but not everything. So systems were a mess, tooling was a mess, project always took a lot longer. And that was sort of the impetus for us to say, hey, what's the problem here? It's the foundational data infrastructure. So let's do something better so that we can help everyone, make it easier for them to manage this type of data. What are the benefits for teams managing all this like multimodal data? If you look at companies that are managing like tens of terabytes to like petabytes or even bigger set of multimodal data, typically it's sort of like this Rube Goldberg machine inside with their data infrastructure, right? So you have your data lake that may be storing a bunch of Parquet for like the metadata, and then you have like some of your raw data somewhere else on storage. Then you're copying all of the vector data into a vector database, and then that vector database is a separate thing that you use for the search, right? And then you have some separate like training data infrastructure because Parquet is not good for large blobs, and then you're like copying data into that training data infrastructure, and then like the results of that then goes into an evaluation warehouse where you're using BigQuery or Trino to query that, and that's separate again. And then some of that data makes it back into your like data curation, labeling pipelines. And so my co-founder Lay worked at Cruise and built out a lot of their machine learning platform and infrastructure there. And I think he went through this exercise of like, if you are a machine learning engineer, going through your daily work and going through that like life cycle of machine learning from the exploration of your data to selecting the right data examples to do training, doing the training and evaluating that. So that cycle, one takes like on the order of like days or weeks, but you have to know like 7 different systems and 4 different languages in order to be able to navigate that one cycle for one iteration. And you guys have worked in ML, you guys know like the success of machine learning and now AI projects really depends on one critical thing, is the speed at which you can iterate and you can improve. When you put so many obstacles in your daily workflow, it becomes very prohibitively expensive. So at a whole system level too, not only does it makes things slow down and way too complicated, but you're copying your data in like 3 different places, and you're doing that at a large scale and on a regular basis. So the extra compute and storage costs are really, really high. So we've had several customers are like, wow, just being able to not have to copy data like for experimentation saves us close to $1 million a year. And then the worst part of this is if you're having to navigate all of this to do your daily job, if you're an ML researcher, AI researcher, you're spending 80% of your time doing like menial data tasks and not really in the interesting part, which is like discovering your data, curating your data, and like doing the actual training and improving the models. And so that's really the big pain points that Lance and LanceDB solves.
Okay. It helps you deal with not having to do as much of the kind of like switching back and forth between a bunch of different systems, as well as like it saves costs for the company, just because you don't have to use as much compute.
Yeah, and the underlying system is like because for example, like the indexing and everything, because it's disk based rather than all in memory, so it allows us to separate compute from storage, so you can scale two systems separately. And so essentially, what that means is like we can serve real time like billion scale vector tables on like one node, and you can scale up the query node separately from the storage, and you don't have to worry about like uh, how do I shard this data set, and then worry about like hot partitions and like stateful systems. So that scale out story is much simpler and much less costly.
Okay. Okay. Um, audience, I'm gonna